Hi, I'm Bennett Alterman, and this is my Lab 3, Analyzing Net Force in a Black Hole Orbit. The objective of this lab is to find the mass of a black hole based on a star in orbit around it, assuming the force of gravity from the black hole is the only force acting on the star. What I've done is I've set up my system to contain only the star. This star has a mass of 1.989 times 10 to the 30th kilograms, and the time step I've included in this experiment is 86,400 seconds, or 1 day. As stated earlier, the only force and interaction at play here is the gravitational pull between the black hole and the star. Through the analysis, I found the resulting mass of the black hole to be about 3.5 times 10 to the 31st kilograms. Here you can see the diagram that I've made for this scenario. You'll notice that the positive x-axis is to the right and the positive y-axis is up. You'll see a red circle denoting the system, which includes only the star. The blue arrow is showing the direction of the gravitational pull. This is the pull, or the force, exerted on the star by the black hole. Here are some important equations that we'll need to use to consider this scenario. The first being momentum, which is found by the multiplication of mass and velocity. Change in momentum can be broken down into different components. This can be broken down into the change in momentum perpendicular plus the change in momentum parallel. Also, the total change in momentum over time is equal to the total forces at play, or F net. F net can also be broken down into components. As we can see, F net perpendicular plus F net parallel will give us our total forces, or F net. The final equation we'll need to note is the magnitude of the force of gravity. This is found by multiplying a gravitational constant g, or 6.7 times 10 to the negative 11th, times the mass of the star, m1, the mass of the black hole, m2, and then dividing this whole thing by the distance between the black hole and the star squared. Here we can see some of the code changes made for this experiment. You'll notice that P initial and P final, or momentum initial and momentum final, were found by multiplying the star's mass times the initial and final velocities respectively. The same was done to calculate the star's change in velocity and change in momentum. Then, to calculate dp dt, we've simply divided delta p by delta t, and we've set that equal to F net as seen in the previous equation. Furthermore, calculating dp dt parallel and perpendicular, what we've done is taken the magnitude of the total dp dt and multiplied it by the direction of p hat, which is p initial divided by the magnitude of that same p. Then, calculating Newton's second law, or using Newton's second law to calculate F net, we can see that F net parallel is equal to dp dt parallel. And then, from there, we can solve for F net because we know that F net is broken down to dp dt parallel plus dp dt perpendicular. Here, we must update the arrow scale to be representative of the forces at play in this scenario. As we can see while the code runs, the green ellipse represents the orbit of the star around the black hole. You'll notice 3 arrows. The yellow arrow is indicating the direction of F net. This arrow will always be pointing towards the black hole. The blue arrow indicates F net perpendicular, while the black arrow indicates F net parallel. You'll notice that at each point in the orbit, the arrows will change in magnitude as the force is changing based on the position of the star. The resulting values are as follows. F net was found to be 1.1 times 10 to the 27th newtons. F net parallel was found to be 4.9 times 10 to the 26 newtons. F net perpendicular was found to be 9.48 times 10 to the 26 newtons. And again, the mass of the black hole is found to be about 3.5 times 10 to the 31st kilograms. I've also labeled the arrows here as well for your just general knowledge in case you wanted to know again. So what does it mean in what if questions? So discussing how F net perpendicular, and F net parallel differ from dp dt perpendicular, dp dt parallel, and dp dt, we can see that F net is the sum of all the pushes and pulls, while dp/dt is a change in momentum found solely through observation. So a change in momentum is a change in motion, which is caused by the forces at play. So we know that the change in momentum over time is equal to F net, and both of these can be broken down into their corresponding parts, dp/dt perpendicular equaling F net perpendicular, and dp/dt parallel equaling F net parallel. For question 2, what we can do, by replacing this black hole with a new one, we just follow the same steps we followed in this scenario and observe how the star is orbiting this new black hole, and go through the same steps using the momentum principle and Newton's second law to again find the mass for this new black hole. Thanks for watching.